completing the square is one of the ways that you can always factor something. There's a very nice, easy process that will always work for any trinomial, no matter what it is. Whether it's something you can factor by figuring out your terms without a hassle, or it's something you don't know what multiplies together. Completing the square will always work. It's nice for solving the equations, because if you do enough of them, it becomes very, very easy. So let me show you guys how this works. I know that you might have seen this in algebra. You might not have spent a lot of time on it. I think Seb did a little bit of it last year in geometry. Very rare. I think in geometry you have what, 6 problems total that have factoring in it. Here we've got a couple more.
No, triangles make it tough because they add a lot.
Yeah, that's true. We use completing the square a lot in algebra too, because after I show you guys a couple of how you work the algebra, I'll show you when we're going to use them later on in the class. So completing the square. Easiest thing to do is start off with an example. Let's say we have x squared plus 10x minus 3 is 0, and I want to solve for the zeros. So up to this point, we always would say what times what is negative 3, but you add it together, you get positive 10. You can't. So think back to earlier this week when we started doing our factoring stuff. We'd say nope, and we go to the next problem. So there's nothing we can do here. Well, wait. Today.
It slices, it dices, it Julian's fries.
Exactly. Here's what we do. We follow this extremely simplistic scenario. This is written as a trinomial. Your basic quadratic equation always looks like this: ax squared plus bx plus c is 0. You guys remember seeing that from parabolas in algebra, I'm assuming?
Yeah.
Now, what we're doing here is that's like your generic form of quadratic. What we work with here are some of the coefficients. Today we're just going to kind of focus in when our a value is going to be 1. Tomorrow we'll go back into when it's not equal to 1. It's a little bit trickier, not by much. And we're going to follow these rules to set this up. The very first thing we're going to do is we're always going to move the value of c. We always want c to be on the other side of the equation. Okay? So, how do I move c?
X squared plus 10x equals...
Here's what I want you to do. There's basically 3 steps to these problems. 4, okay, sorry, there's 4 steps to these things. The very first thing you always want to do, move c. So, x squared plus 10x. Here's a little trick. I'd like you to start doing this. Blank equals 3 blank. There's a reason why I'm putting that blank in there, and I'll show you why in a second. Yes, ma'am.
Wait, what did you say the original one was?
Ax squared plus bx plus c. Sorry, oops. Your generic formula is your ax squared plus bx plus c is 0. When you work with quadratics, there's a lot of stuff going on with the coefficients. When we go back to graphing these things, you'll see why we use the a, b's, and c's here. Oh yeah, we spent a ton of time graphing this. All right. Now, not tonight. At this point here, has everybody moved c?
Yes,
sir. Okay, that was easy.
Now on to step 2.
We should poster these steps right here.
Half of b. What I want to do is find out what half of b is. Well, b in this case is how much?
10x.
All right, so here's what I do. Below this, for all of you that always do horizontal math, we're going to do vertical math today because life is easier.
Yes, I understand.
What's half of 10? 5. 5, good.
People do it, it's stupid.
What's 5 squared?
29.
Step 3. Take that and square, add to both sides. So to keep this balanced, I'm going to add 25 to the left 25 to the right. What I want you to notice what we just did to the trinomial. What times what's 25 that you add together to get 10?
We just make up numbers.
5 and 5, isn't it? You just created a perfect square. Because what was half of b? 5. Wait, what? What's that? Yes, you are. Half of b was 5. What times what's 25 you add together to get 10?
5.
5 and 5. So your term is x plus 5 quantity squared equals, what's 3 and 25?
20.
Doesn't that look like a problem you solved 2 days ago? What you are doing here is you're factoring by completing the square. You're solving your zeros by completing the square by turning this garbage-looking trinomial into a perfect square, which is very easy to solve at the end now. Because how do I solve that? Yes, sir.
Where did you just get the 25s from? Did you just like make them separate or something like that? Why can you add it to both sides?
Whenever you take an equation, it's a balancing act. Do you agree?
Yes.
So if I add 25 to one side, what do I have to do to the other?
Add 25.
Isn't it still the same equation then?
Yeah. But
What I'm doing here is I'm changing the shape again. I'm changing the shape of the way the equation looks to make it easier for me to work with. Just like multiplying by factors of 1 with those conjugates. I'm changing the shape to make it easier because now x squared plus 10x plus 25, I can factor it to the quantity x plus 5 squared, tack on the 25 over there, and it equals 28. Because now watch what happens. Yes, ma'am?
So in the parentheses, will it always be x plus the new b squared?
Unless it's a negative. Because sometimes this term could be minus 10, your b value could be negative 5. I'll show you in 1 second, okay? So how do I solve this for x? What do I do now? Square root it.
Square root it.
I took a square root over an equal sign. What do I have to do?
Plus or minus.
All right. What's the perfect square that's hiding in 28?
2. Well, 4 to 2.
Does everybody agree it's root 7?
Yes, sir.
Okay. How do I move to 5?
You subtract it here.
So my zeros of this function
Well, that's.
How do you graph that?
it's a decimal equivalent.
Just don't.
Okay.
Think of it this way. These are those types of problems that if you did, remember what in Algebra 1 you guys graphed parabolas? If you were graphing something that was coming around, it was coming between 1 and 2,
Yeah.
there's some decimal value. Well, there's some decimal value. I don't know what it is. I don't care what it is. All I know is that it's negative 5 plus or minus 2 root 7 are my zeros.
Okay.
That's it.
So you said there were 4 steps, what's the fourth one?
Enjoy.
Basically it. Bless you. If you think about it, it is solved. Once you add, once you take half of b and square it, add it to both sides, it becomes that trinomial, or excuse me, it becomes that perfect square, and it's just really fast from that spot. Okay, yes, ma'am.
Always work.
Always works.
Even if
Maybe.
you solve it the other way?
Yeah, absolutely. Hey guys, like I was saying, this is always going to work, even if it is something that is factorable. Okay? Yes, sir.
Like, just one question. Why is it plus or minus?
Whenever you take a square root over an equal sign, you always put plus or minus. Remember we talked about that yesterday? What's if you take the square root of that, what are two numbers you multiply together that are 9, 3, or negative 3?
No.
That's why we write plus or minus.
All right.
Okay?
That's hard to stick with. We've never had to do that before. So
We don't want to have a mix-up there.
Let's try another one.
You don't want to go up.
Let's try another one. So x squared minus 16x plus 76. Once again, these are large numbers that I do not want to multiply together to trifactors. It's going to take forever. I don't care. But if I go to complete the square, it's fast, it's efficient, and it's a very systematic approach to this factoring. I know how a lot of times students always go, I don't know what are two multiples. Well, completing the square is one of those things that you guys can always fall back upon, because it's a, I don't know, it's a rule. You do this, do this, do this. So what's the first thing I'm going to do? Move to 76. Okay. You need a calculator for half of 16?
Oh, no, but would be.
I'm messing with you. I've done that all day today. So when I always hear a calculator, we do this part. So take half of b. Well, b in this case is negative 16. Now, Jessica, this is where you're asking here. See how negative 16 divided by 2 is how much? Negative 8. You get negative 8. When I square negative 8, what do I get? So I'm still adding 64 to both sides. But what was half of b equal to? Negative 8. So in the term, it goes.
So it's then x plus the half of b.
Always, yes. This half of b value, guys, whatever it is, whether it's positive or negative, is always in your term. It's always in the parentheses. Always, always, always.
Always.
Yes, sir.
Like, when I was doing that, I forgot that, like, when you square it, it's supposed to, like, be positive. I wrote it in, like, negative.
It'll be wrong then. You gotta make sure you're positive.
How many points would you break it?
The whole problem will be wrong then. You gotta catch that. You have to catch that. Trust your brains, guys. Your calculator will, if you type in negative 8 and square it, your calculator's going to give you the wrong answer. Okay? Your calculator's going to give you the wrong answer.
What would it say?
Negative 64.
Oh, stupid calculator.
And just the SMRT.
SMRT.
Now, what do I do? Square root it. What's the square root of negative 12, guys?
2i root 3.
Wrong.
2i root 3.
Wrong.
Plus or minus? 2i root 3.
Thank you.
I wrote it down. I meant to say 3, not 4.
Sure you did.
Now what's the last thing? What's the last thing you're going to do now?
So you didn't write it?
Remember how yesterday when we started talking about imaginary numbers and we said, hey, all of your homework, all of your possible questions can be asked have now doubled? Well, there you go. This is what happens. Sometimes it's not that difficult. It really is. If you're blending what we've worked on over the past couple of days.
Why is the negative 8 negative? Because you got
What's half of negative 16? What times what is positive 64 if you add together to get negative 8? Or negative 16? Negative 8 times negative 8 gives you, okay? You're creating that perfect square. Your perfect squares can be, you know, something minus or something plus. Yes, sir?
We should teach imaginary numbers in kindergarten. I'm going to go to my local elementary school and teach them.
Teach him I.
Teach them what I is.
I means myself.
I is B. No, I is square root of
Oh, which
one.
one is it?
I is B.
I like hair.
I don't want to answer.
Easier to write to write.
Sorry, this didn't work out. Oh. We'll get to that.
This is another problem.
He's smirking over there. There's something going on in this problem.
Yeah. You can't answer. I'm looking down right now.
Let's see what happens.
Oh,
Oh, do we have to take a GCS?
Wait,
Hold on, just try it. I will talk about it in a second. I will talk about it in a
Don't
second.
even say anything, Genjo.
Oh.
Don't do it.
Oh, I see. I see.
I see what you did there. Get I
see what you did and I don't like it.
I'm assuming at this point in time, most of you guys picked up that this is already set up.
Yeah.
paradox.
Has anybody, did anybody automatically, since we've been working on the past couple, subtract 100? It's fine.
Yeah,
Yeah.
It's fine.
I did that.
I want to show you that it works.
It's a paradox. It can't be solved.
Paradoxes are different.
If you set it up this way, it still goes the same route. What's half of 20? All right, so your term is x plus 10. What's 10 squared?
100.
Okay. Ladies and gentlemen, it's enough. Okay. What's the square root of 0?
0.
0. What's your 0?
That's weird.
Is it okay to have 1 0 per parabola? What does that mean?
It's a straight line.
That would be a parabola. It's
It's
on it, yeah. It only touches it at one spot.
Oh, yeah,
Okay.
you're right.
Now, I know when I wrote this out, so you guys started going, and you all of a sudden went like this. Yes, you might have recognized right away it was that. When you see that, that's okay. But do you see how, if you forgot everything, it still works?
Yeah.
Right? It still works, yes.
Would you?
That's squared.
Oh, I think
Remember, you take that and square it. One of the things that people have been messing up and not having a good old time with is what happens when your second term is odd.
You just do half, like, over a fraction.
I'll show you. This is where people tend to go, oh my god, I don't like math because there's a fraction.
There's a fraction number. Where?
Okay.
Oh.
Now,
I don't see it.
I'm going to walk you through how it sets up. You're going to do the exact same thing.
Oh, yeah, I see it.
Now, for those of you guys that are still using slashy fractions, please convert to vertical fractions. Okay? Now, according to completing the square, what was my first step? Move the c value, right? Okay. So add 1, I get x squared plus 3x length equals 1, 1. Now, half of b. Well, 3 over 2 is half of b. Do you agree?
Yeah.
If I square 3 over 2, that means I have to square both the numerator and the denominator. What's 3 over 2 squared? 9 over 4. So I'm going to add 9 over 4 to both sides. Okay? All right. Now, what was half of b? So there's your term. X plus 3 halves, quantity squared equals, well, 1 plus 9 fourths gives you 13 fourths. Because 1 can be rewritten as 4 over 4. You guys okay with that?
I cut him off. I'm sorry, guys. That's a hard apology. Colin normally gets all of that because I just.
We okay?
Yep.
No. 1 plus 9 fourths. 1 can be rewritten as 4 over 4. 4 over 4 plus 9 over 4 is 13 over 4. I got a common denominator. That's all.
So you just made it so it's square.
I just made a common denominator. That's all. I took the value of 1
Oh, yeah, never mind, I get it.
and just rewrote it.
Oh!
Now, at this point, what do you do? Square root it. Now, again, this is where a lot of people that do slashy fractions forget, because it's the square root of the entire fraction. When people write slashy fractions, they think it's just the first part. So, the square root of 13 over 4 would be just the square root of 13 over 2. So I have x plus 3 halves equals plus or minus root 13 over 2. What's left?
Minus
Subtract it over. Notice that working with the fractions isn't scary. Keep it in a fraction. Trust the fact that you know what you're doing. You know what you're doing. Trust it. You know what you're doing. It's better than never.
That is true.
Okay. Now, one of the reasons that we spend a lot of time working on completing the square is when we get into what the section is called conics. Conics are different shapes of curves. Hyperbolas, parabolas, ellipses, circles. Each one of those can be written in terms of a perfect square. When you get into what looks like a hyperbola
Oh, it's those things?
It's a basketball.
there's all these different values of stuff that you're able to do within a hyperbola. Now, this is not going to be, this will be shifted way off into a corner. But the equations of these things are written as perfect squares.
You lost.
Stop it.
Oh, sorry, it's equals to me.
Oh, that's
It is a K. Now, what happens is instead of having a singular trinomial, it'll have it written out as like 6 terms, and you're going to complete the square over 2 different variables. You wind up doing it twice. It looks awful, but if you understand how to complete the square, it's nothing more than just adding and subtracting. It's not difficult, but it allows you to plot and get coordinates for the hyperbola. Yeah.
Didn't we do the comics with the thing where it was like, where x minus 1, then it's kind of x plus 1?
Yeah. Conjugate. That's awesome. Terrified for that.
Wait, which is?
Nothing. All right. The other thing that we're going to do tomorrow is we're going to work more into the ones that have, the leading term coefficients. It's not extremely difficult. It's just a couple extra steps. So tomorrow we'll blend this part in as well as quadratic formula, which I know you guys have all done, so it's not going to take very long. And quadratic formula is annoying, in my opinion, because it takes a long time to go through it, and you can make too many simple errors. Completing the square is systematic, and it works. What's that? You can barely stay awake right now as it is. What I want you guys to do is on, what is this, 287. So for tonight,
But I got online.
just gonna give you a couple of them to start with.
Oh,
Okay.
that's so nice.
Wait, is that all tonight?
Count again, guys, it's not 5 problems. Thank you.
You should have done it even.
Double it for you.
Alright.
Every other even would have been nice. If you're gonna make it.